All right. Welcome to this week's session. This week's wonderful session of Unity Technologies live training. We're the second in this week's. We've done two this week. Today's session is communicating between scripts and game objects. Today is a relatively basic beginner episode for what we're doing. So today we're going to talk about scripting and communicating with game objects and components. Unity has two important faces. Unity has scripting and Unity has the editor. And scripting is where we're writing all of our instructions. The editor is where we get and set up all of our game objects in that physical way. Let's go ahead and bring up, get that off 2D. There we go. 3D world there. So this is our editor. And we need to bridge that gap where our game will be. We have to bridge that gap between the two, between that the scripting side and the editor side. And then our scripts need to know our game objects. They need to know the components on those game objects, and they need to pass data back and forth. And sometimes it's convenient. We've got components on the same game object, and sometimes we have to find other game objects and then get their components off of that game object. The workhorse, the primary workhorse for being able to pass information and instructions back and forth is references, and we store these references in variables based on the type in our script. The most common way of doing this is to make that reference and to populate that reference in the inspector. So let's go ahead and see that in action. Let's create a new C# script, and let's just call this example script. If only I can type. There we go, example script. So we've got our example script. Let's open that up in MonoDevelop. And we create our references as variables at the top of the script. So let's create one. Let's create a game object reference. So game object, and let's just call this my game object. And I'm going to save this, and let's come back and look at this in Unity. And let's put this example script on our main camera for now, because scripts need to be attached to game objects in the game to be able to work. So I've created this example script. It's attached to my main camera. I've created a variable, and I can't see it. The reason for that has to do with our access modifiers. Now, Mike, who's here with us, wrote some very good documentation, which you can find on our site, and I also believe has done some live sessions on access modifiers. But let's talk about that. This variable is made with a type and a name. And with C#, if we don't explicitly make this public, it's going to be a private variable. So to be able to see this in the inspector, we must make this public. We must make this a public variable. And then we can access it both from other scripts, and we can see it, serialize it, and access it from the inspector. So again, the most common way, we have our public variable. We look at that public variable in the editor, and we can see that there's now a slot. There's the name my game object, and we can see that it is not populated, it's got none, and that it is looking for a game object. So let's just go ahead and make a game object, and we can populate it. So we can just drag that in. So this is the most common reference, is to make a public variable in our script, to have a game object or a component on that game object in our hierarchy, and simply drag it in, and now we can start to communicate with that particular script inside our script. Now let's go take a look at this in action so we can do something with it. So now that we have a reference to our game object, we can do things with it, like in update. We can say my game object, and then we can access components on that game object using the dot. And so what I would like to do is talk to the transform. I want to talk to the transform on this game object. So we have our game object, and we want to get hold of the transform. So there's the transform. So we can affect the transform by getting the game object reference, and then we can find the component on that game object. So I'm going to do transform.position. And then let's just say it's going to be equal to vector3 dot up, and then times time.time. And if we come back to Unity, we have a reference we've written as our simple script. Let's save the scene. So I'm going to save this in assets. I'm going to save this in a new folder called _scenes. And then let's save that as our main scene. So we've just saved the scene. So when we hit play, we're now affecting that game object. I'm not holding it. Sorry, I had the wrong one selected. So there we go. We can see that the game object is rising up in the game. We can see that by the location. This game object is empty. It doesn't actually have any physical presence in the scene. So, but what the point I want to show here is that the game object, it can take any game object. So we can create anything that has a game object, and the game object is the root of all of the objects that we have in our project. So let's create a sphere. And we can then, in our main camera, on that script, we can use any game object. In this case, it's the sphere. As long as we have a game object, as long as the slot matches that type, we can use it. So that we can now, in this case, rise up the sphere. So it looks kind of boring, so let's go ahead and add a directional light so we can see that. And we can see that that's rising up. So we've made a connection. We've got the script on our main camera affecting another game object and affecting another component on a different game object in this scene. Now, when we look at the script, we're taking the game object and then we're finding the transform and then we're affecting its position. And the transform position we can see up listed here as a transform position. But we can also grab that transform directly. So what we can do is change this public variable to a transform. And let's call this my transform. And then let's affect that transform directly. Now when we come back to Unity, we're going to see that that slot has changed. That slot now has a transform slot. Now we only have control over the game object, dragging a game object. So I can't drag this transform into that slot on the main camera. But Unity is smart. Based on the type of the slot, all we have to do is drag the game object itself into the slot, and Unity will find the transform component from that game object. So we can see that we're looking for the sphere. We are looking for the transform on the sphere. So now we are grabbing this component directly. So we're not getting a component overtly. It's done under the hood. So by dragging that reference, because we've made it as a type transform inside the script, that when we go ahead and we hit play, we're now affecting the transform directly. So as opposed to going through the game object. But what happens if we fail to populate this? So we now have made a reference. It is possible to have nothing. So if we have nothing inside these slots, we can, in our script, look like we have a proper connection. We've made a properly written script. We've asked for the transform. In our update, script is written perfectly correctly. We're saying take that transform position and make it equal to vector3 up times time.time. But when we come back and we hit play, inside Unity, we are going to get an error. And that error is going to be a null reference error. Essentially, we have a reference, and we are looking for something, and it doesn't exist. It's a little bit like the analogy that I was using in another session was you want your car is parked in a valet parking lot, and if you don't have the ticket with a number on it, even though it's you know which car you want, you have to hand the valet a specific ticket for that specific car. So we have a perfectly valid script, and this is a runtime error. We haven't set up our game properly, and we can, if we follow it through, we'll see that it's this line. That's the problem, but it's not a problem with the script. It's a problem with the way that we've set up our scene. So we can go ahead and fix that simply by populating this. Now, if we can't populate this in the editor by clicking and dragging, we can do this inside scripts. So if we can't populate our connection in the editor, When would that be? Well, I mean, if we want to have a speedy workflow, if we want to automatically reference other components with a script, so it's ease of use, we can simply drop that script onto a game object and have it work. That's a time when we don't necessarily want to populate things here in the inspector. Also, if we're instantiating game objects at runtime, and we'll see that when we come up in a little bit, if a new game object is instantiated at runtime and it needs to populate a reference, we can't do that in the inspector. So it has to be done in code. And so that component needs a reference and it needs to know how to get it inside our script. So one of the ways that we can do that, if we look just simply at components, and we'll look at game objects in just a moment, we can have on a game object, we can have one component find another component on that same game object. So let's go ahead and take a look at our script. And if we look at just simply getCom, we can see that there are quite a few different get components. So we can get component, singular, we can get components, plural, and we can also get either a component or components in the children, down in the hierarchy, or up in the parents. So let's go ahead and take a look at get component. And then I'm going to take a look at these in the documentation. So I'm going to do another quick shortcut. So if I have something I want to look up in the documentation selected, go ahead and hit Command on the Mac, Control on Windows, and then the single quote key. And that will bring up the documentation page in another window. Let's bring that over here. I've got Twitch open. So we can see that we have get component both by game object and by component itself. And then there's the get components in children and in parent. Looking at the singular version, I want to take a look at these a little bit more closely. Why do we have two? We have the component and we have the game object, and they both generally do the same thing. And as an aside, we're going to be dealing with the generic version of this, which is, if you look at this, the generic version, we end up using angle brackets and then parentheses at the end. With inside the angle bracket is the type that we're looking for. So all of these get components are looking for components by their type. And the advantage of having both a game object get component and a component get component is essentially syntax and also some ease in the way that we write some of our code. When we are looking for a component on the same game object, we can simply say get component and then get the component that we're looking for. If, on the other hand, that we have access to another component, like the transform or a collider, because sometimes when we have collisions, we are given a collider. If we're using raycast hits, we find other components. We can simply use the component version of this, and we can say, you know, I'd like to find the rigid body and then get a component. When we're looking at the get component, and we'll get to some of the other ones in a moment, there are two ways we can look for it. We can look for things with the type itself, and then we can also give it with the string. If we go ahead, oops, come back here, don't do that. When we're looking up components via string, we also have to cast for them. Let's bring this up a little bit. And the best suggestion is to look for these via type rather than by a string, because when you look it up by string, it's a lot slower, and you also have to cast that component that you found as the component you're looking for. So let's see this in action. So if we're wanting to write a script where we can simply get a component on the same game object, we can use get component. So let's make a reference for it. We first need a reference, and this is going to be a private reference because we're going to get this reference within the script. It doesn't need to be public. So let's make a private reference to say a rigid body, and that rigid body, we'll just call that my rigid body. And in start, we'll say my rigid body is equal to simply a get component, and the component we want to get is the rigid body. And that's done in angle brackets because we're using the generics, and then followed by a parentheses. Now, this is presuming that there is a rigid body attached to this game object. Now, we're going to attach this to in our game. We're going to attach this to, let's move this from the main camera where we have it right now. I'm going to take this off, remove the component here, and I'm going to add it to my sphere. But if I want to guarantee that there is going to be a rigid body, I can also use the require component. So let's take a look at require component. So if we take a look at require component, again, command or control and single quote, we're going to go ahead and look at that in the documentation. We can see that require component is an attribute, and it lets us automatically add required components as a dependency. When we have this attached to our script, which in C# you put just before the class, then it will make sure that there is a rigid body. There must be a rigid body attached. And if there isn't a rigid body attached, then it will go ahead and add one. So let's go ahead and copy this. And I'm going to paste this in above my class. So now, not only am I requiring that type of rigid body, that component type of rigid body, I'm accessing it. I have it private as a reference, and I'm getting it here in start. So let's save this. Let's come back. We can see that the sphere doesn't have the script and it doesn't have a rigid body. So let's grab our example script and put it on the sphere. Come back and look, and we can see that we have our example script and we have the rigid body that we have here. Now, let's go ahead and do something with this. I'm going to go ahead and just comment this out in my transform, and I'm going to go ahead and write rigid body, or my rigid body, excuse me, my rigid body, add force, and let's add force vector 3 up, vector 3 dot up. I don't know, let's say time about 10, something like that. So let's save that, and let's come back to Unity. Hopefully the compile gods will be happy. Oh, okie dokie. And let's go ahead and hit play. Oh, not enough force. It was a good guess. Let's make it a little bit higher. Save that. Woof! And away it goes. So, we have found that automatically, and also with a little bit of that sugar that we have on the top by being able to require the rigid body, we can start to simplify our script so that we're not hooking up everything by hand. We can attach the script, we can require the rigid body, and then we can find that local component directly without having to attach the script as a public variable and then drag that rigid body onto the slot. So when we're looking for components, this is looking simply for a component on the same game object. You can also look for component or components in the children. And when we're looking for a component or looking for components, I think it's important to note some very important things about them, which is when you're looking for the singular, there's singular and plural. There's get component and get components. And the first one, when you're dealing with the singular, which we're looking for here, it will return the very first and only one item that it bumps into. So if it's looking for a component in the child, and there are multiple versions of it, it will simply find the first one and return that. On the other hand, if you look for the plural version, components, we can see that it's returning an array. So it's going to return a collection of the components that it finds. So you can find more than one, you will get a collection of them, you'll get an array of them, and then you can iterate through that array or somehow manipulate that array to find the components and use the components that you want. So let's take a look at what happens if you don't have a reference to the game object itself. Actually, before that, I've got one other thing I do want to show you that I prepped. I lied in examples. Let's take a look at sparks. I've got a Unity spark generator. And this is a collection of particle systems. And each child here has a particle system on it. And if I want to control all of them, I need to be able to reach out and grab all of the components in these children. So let's take a look at the Sparkle controller. So we've got Sparkle controller, and it has a private array of sparks. These are particle systems called sparks. And in start, we say that our sparks equals the get components in children, and the type is particle system. So when we put this script on the parent, it's going to look down into all of those children and find all of the particle systems. And then I've got a little thing just so it rotates, which is a bit fun. And then if the input is the key code of E, if I hold down the E key, it's going to look through that list, and it's going to start doing things. Just look through that array and start doing things to all of the systems, particle systems that are in it. It's going to pause them and then emit a big bunch of sparks. So when we take a look at that, so we're going to put that onto that parent, and then when we hit play, we can see that each one of these is emitting sparks as we go. But if I hold down the E key, boom, it turns them off. And every time I hit it after that, it goes ahead and emits a whole bunch of sparks from each one. And so that's one of the ways that we can use this get components in children, so that you can create a private list, or private array in this case, and then you can get your components in children and populate it into that array. And then we're using the for each loop to go through each one of these particle systems in that list. What do we do if we don't know where the game object is, if we have to get the game object? Well, we don't get game objects. I think one of the important things is to look at the nomenclature that we have, which is there's get and there is find. We get a component, but we find a game object. So if we're going to look at finds, if we've got to find a game object, so let's go ahead and look at this in the documentation. This is just simply showing us find object of type and find objects of type. So again, we have a singular and a plural. So command on the Mac, control on Windows, and we can see that there are a bunch of different finds that we have. We want to look primarily at transform find, game object find, and our find objects of type, which we're going to skip over relatively quickly, and then we want to look at find with tag and find game objects with tag. When we're doing our finds, you can find by name, by string, which is what we're doing with the GameObject.find and the transform find. I only want to cover these very briefly because they're relatively slow, and most of the time, if you need them, you already have the object, and it would be easier to create a public reference and then go ahead and drag that public reference, and rather than trying to find it with a very long and potentially error-prone string. But it's good to know that they're there, is that you can find a transform in your children. You can give it a path, a string path, as long as you have that slash character. It says here you can traverse the hierarchy in the path name. The same with GameObject.find, is you can find game objects by name. But again, unless you absolutely have to, I wouldn't use either of these. And also be aware that these are particularly slow. And so if you do that, you should definitely make sure you do it in start the way we have, and cache that reference. The next ones that you should also arguably know they're there, but only use in extremis, is you can find game object or game objects by type. So you can give it a type. And again, if you have one object, you're looking for one object by type, you will find the first one and return it. So if you say, hey, I'm looking for a rigid body, it'll just find the first rigid body at random. Unity will hand it to you and go, there's your rigid body, son. On the other hand, you could get all of them, and these only return active game objects. So if your game object is inactive, it won't be found. And lastly, the ones that are more common are tag. So you can find game objects with tag, and I must have not linked it, find with tag. So let me just get rid of these. So these two look for the tag that we set up in the tag manager. And even though this is not the fastest, and again, if you need to, it's best that you do it in start. It is probably one of the better choices, because you're reducing the number of things you're looking for based on the tag that you yourself have created. So let's go ahead and take a look at what we would do with this. So let's come back to Unity, and to show this, let's write a new script. Let's write a script called spawner. So let's use these sparks. Let's use the sparks that we have set up. I've got a Spark game object, Spark prefab that we can use. So I'm going to use this to spawn prefabs. And so let's create, and to put it on something, let's go ahead and create a game object. and let's call this called spawn. Let's add a we can see this. Maybe most people don't use these. Let's go ahead and give it a little icon. So we've got spawn, we've got an icon on it. Let me close down the spark generator here, turn it off. And then let's duplicate this. So we have a couple of these, maybe 4. And let's drag these around just so that we have them out in our scene. So we just have, I'm just quickly making 4 little spawn objects with this. Oh, and I didn't do one thing that I should have done before I duplicated them. That's all right. Let's create and add a tag. If I had added that before I duplicated them, I wouldn't have to go through this. Oh, I've already made my spawn. So we've got this tag called spawn. And you do that by creating a tag in the tags and layers. And then you can go ahead and add that tag to each one of the objects. Or can you multi-select for these? Oh, you can. Very nice. Oops, completely blew that. So let's multi-select our untagged objects. Let's pretend we never did that. And then go ahead and add spawn. So we now have 4 objects in our scene that are have spawns. They've got their nice little icons on them. And they're tagged with spawn. So we can come back to MonoDevelop. And in MonoDevelop, let's create a public reference again, which we will drag, a public reference. And it's going to be to a game object, and it's going to be sparks. And we're going to use those sparks to spawn those sparks. And private as well. We'll make a little private reference, and that's to a game object array, only if I use the correct symbols, called spawners. And in start, we're going to say our spawners is going to be equal to game object. And note that this is the capital game object, because we're addressing the class. We're not looking for our parent game object. When looking at this game object find objects with tag, we want the capital because we're addressing the class directly. We're not addressing the instance of the game object that we're attached to. Because with that lowercase g, we're simply looking for our game object instance. And so then we're going to say dot find objects, the plural, with tag. And what is the tag? Spawn. And then we want to invoke something we're about to write. So invoke repeating. And what are we going to invoke? Something just called spawn. And we're going to wait 1 second and then do it every second. Every second. Let's do it every second, folks. So, and what are we going to write? Spawn. And spawn is going to simply be our game object. Spawn. We're going to grab this as a spawn point. Is going to be equal to learn to type our spawners, and then we want to take as the index a random range, and our random range is going to be from 0 to spawners dot length. And then once we've grabbed that game object from our array, so we have an array of all of our spawn points, and then we're going to instantiate. Okay, it worries me when I stop getting code completion. It makes me think I've got some horrible error going on somewhere, and I don't know what it is. But I can write it out by hand. We want to instantiate our sparks at our spawn position, or spawn transform position, and at quaternion.identity. So with no rotation. Now, we have that. Let's put our spawner on the main camera. So it just sits here. Oh, where's our public variable? We've got an error somewhere, parsing error. Okay, where is it? Oh, I'm missing my final bracket. Must have nipped that out by accident. So final bracket. Instantiate. I spelled it wrong. Instantiate. There we go. I love it when code completion works. So now we've got this script. It's attached to our main camera, and it's going to go out and find all of the spawn points that we have in the scene. So if I've added my spark, so that's my public variable. I've dragged that into location. But the spawners, that's all done internally. Private reference, done here in start. So let's go ahead and hit play. We can see it's finding at random these spawn points, and it's spawning this emission that we've got going on with our little particle system. And this is a really good workflow, because if we had, say, a game controller or player script that needs to know all of the spawn points on a level, and we could make that a public list or public array, but we don't want to have to hook them up by hand or change a value on that component, on that spawner component, every time we change an item in the level. We can place our objects in our scene as we feel. The game controller or player script will find all of the spawn points when the level starts. So this is good for when we're making our scenes and we're making our levels. It's an improvement of our game creation workflow. We can put those into the scene as we need them and then have them found by tag at the start of the scene. There's another case. There's a point where you need to find references to game objects, or you need to find references to components automatically. And that's often when you're instantiating an object in scripting, you create that object in a script, and then it needs to find a reference. If you imagine the case of a game controller or a message manager, that you want to be able to instantiate an object, and it needs to find the game controller, needs to find that message manager. How are you going to do it? Well, one of the ways is to use a modified, what's called a Singleton pattern. And I'm not going to discuss even patterns. I'm not going to discuss the Singleton pattern, but I'm going to look at this. This is essentially a static reference that you can hold and make accessible to game objects as they're instantiated. So if we look at an example I have here, a my controller script, what we have here is we take a private static reference to an object of this type. And then we have a public static function called instance. And we say is if that static reference is empty, then we find a game object of type, and the type is this type my controller, and we make sure it is we cast it as my controller. Then we do have a little bit of insurance here, which is that if after all of this my controller doesn't exist, it's still null, then we throw a little note into the log with a log error saying there needs to be at least one active controller script on a game object in your scene, and then we return that reference for the objects that ask for it. So to see this in action, let's add this my controller script to the main camera. So I've got this my controller. It doesn't actually do anything, but pretend that this is let me turn off the spawner script, but pretend that this is my controller. This is a game controller or a message manager, something that you're using to control systems inside your game. And what I have over here, a little UFO. Now this is made entirely of primitive spheres, crushed and squished and changed in size. But we'll use this as an example of instantiating an object. And if we look at the UFO controller, it's got a very simple setup here, which is that it has a vector 3 for direction. And then we just get a random direction. And we're doing that by getting a random inside unit sphere. So we get a random vector 3. Essentially, inside unit sphere delivers us a random normalized vector 3. And then we want to move using simply transform translate our direction, and then we multiply that by time.delta time. So essentially we're going to spawn these UFOs, and the controller will push these guys out at random directions. But let's say we instantiate one of these guys, and the UFO has a UFO controller on it. And we want to have a public reference to my controller, Let's just call it my controller. So there's a public reference. So we in theory can drag this slot. So there's the my controller reference. So we've got my controller sitting here on the main camera. And so there's our UFO, there's our asset, we want to instantiate it, but we can't drag it. This annoys a lot of people. But if you think about it, it makes perfect sense. This is an instance. This is an instance of my controller script. It sits in this particular scene. The UFO is an asset that can be instantiated in any scene. So it actually doesn't make sense that the asset is maintaining a reference to a particular instance. I mean, there's more to it behind the curtain than that, but if you think about it just sort of logically, an asset sitting in our project shouldn't be able to hold a reference to an instance in a scene that may or may not exist in the future. So when we instantiate this UFO and it goes into the scene, the UFO controller needs to find that my controller instance on the main camera game object. So we're going to do that. First thing I'm going to do, make it private. If I can't see it, if I can't manipulate it, if I can't change it, I don't want to see it in the I don't want to see it in the inspector. And then we can say in start, let's do that here, that my controller is equal to that my controller class dot instance, which is both static, the static reference, and then we can use it. Let's call something on my controller. Let's write something. Let's see that. Let's see that. There's my controller. Let's do something fun here. Let's write a public, and now this needs to be public. If this access modifier was private, we wouldn't be able to do what we're about to do. So let's make this public. A public function called found me. How about found me? So we can see that they've been found. Oops. And let's just throw something into the log. Debug.log, found me. And with that saved, we can go back to our UFO controller and do my controller dot, ooh, not dot animation, good, great gravy, dot found me. So we save that, and let's use spawner. Back to the main camera. Let's turn spawner back on. So there's our spawner, and I want to change from sparks. I'm going to spawn that UFO. So now our little spawner script is going to start spawning UFOs. And what we should see, let's just put this down here, is our console should start to be, if I've done everything right, fill up with found me's. Yeah, you can see that every time one of these new UFOs shows up, it finds that reference to that my controller using that static reference and then registers itself. Looking forward, a lot of this is all about grabbing references. And you can also look for returned references to items. If we take a look at that spawner and look at that instantiate, and you look at command single quote or control single quote instantiate in the docs, it optionally returns a reference to the object that we have instantiated. And coincidentally, you can cast for this to any component that happens to be on the object that you're instantiating. In this particular reference, they're casting this as a rigid body, so you can get a reference to the rigid body. If you wanted to get a reference to the collider, you could do that as well. But the important thing is, and it's a lot like 6 degrees of separation, is that when you create an object, I mean, one of the problems that we have with this particular game that we have set up, this particular example, is that we've created all of these UFOs, but if we wanted to do something with any one of these UFOs, we would have a very difficult time finding that particular UFO. We could do GameObjects.find. We could find by name. They all happen to have the same name. Finding the specific one out in this mass of game objects is not really easy. So one of the important things to do is to grab those references and keep a hold of them. In this case, instantiate is returning a reference to the object that you have instantiated. So we can say in our instantiate that we want to create a game object called clone in this case, and it's going to be equal to that which we instantiate. We do need to cast for it. And so in this case, we're going to say as game object because we want the game object. And then we can collect them. We can do stuff to them. We can say our clone.name is equal to I don't know, UFO in string, please. UFO dash. This will be ridiculous. Time. Ooh, this should work. It's a string. You know, so we're giving it some strange, unique name. We've grabbed a reference. We couldn't do this if we didn't know which UFO it was. We can also put them in a list if we wanted to. I'm going to quickly do things here using system.collections.generic because I'd like to have a generic list. And I can now create a new private list of game objects. What should we call it? UFOs. And we can add them to it. We can say UFOs.add clone. So we can put them all in this list, and later we can go ahead and do something with the things that we have created. But we've got a hold of them. We've grabbed them. They're not some random game object just floating around our game that we have no control over and no real easy way of picking out of the soup of the game that we've made. Oh, I haven't made a new one. We have to create a list. Our UFOs has to be equal to a new list. Game object, of course. Sorry, it's not thinking about the technical side. There we go. And so we're now building a list out of all of these. Oh, that's nice. They were so even because we were on the second. We don't get some nice long string, nice random string there of UFOs because we're right there on the second. So it's about grabbing references. If you look at on trigger enter, if you look at on collision enter, we're given references to other colliders so that you can then grab the game object off of that. So you've got your references. You can move these references around. There are examples of if you're playing a card game, you want to put all of your cards in a list with a reference to them. But if you want to start dealing them out, you could create another list, move those references over. So it's all about grabbing references, finding easy ways to have people communicate with each other, finding and using those that static reference so that you can instantiate new game objects and they can simply find that game controller or that message manager. So this is sort of where I got to. This is communicating between game objects and components. So I'm going to go ahead and throw up our normal sign off and then stick around and we can answer some questions. So thanks for coming. Follow us at Unity 3D. Follow us at Mike Geig, who is so conveniently sitting there answering all of your questions. At Will Goldstone and myself, Adam Buckner, at The Ant Ranch. So Q&A, let me know what questions you have. Mike is answering them quite well, but if there's something that you want to see shown in the editor that I can explain, that would also be useful. If you use tag in onTriggerEnter for get component, is that very cost effective? Find with tag is using a string, so it's less effective than some other ways. It depends what you're looking for. In one sense, is that if you know you want to destroy everything that with a rigid body, or you want to destroy everything that has a particular component on it, you could say, I'm looking for this particular component, and so you're not looking things up with a string. On the other hand, and if you have things tagged, it's sometimes easier if you've got 4 game objects that are all very similar, except one is tagged with enemy, and you want to destroy the enemy. That may be one of the easiest ways to do it. Question from Shadeless. If I want to control more different types of game object, do I have to use more singleton controllers? Well, it depends what you're trying to do with them. The example that I'm showing here specifically is that if you have a game controller that needs to know where other things are, and an example, if you look at the Space Shooter project, enemies that are instantiated, when they're destroyed, need to tell the game controller that they've been destroyed, and the game controller will count 10 points towards the player's score. So those game objects need to register themselves with the game controller. And we don't go into the static references the way we do here. In that particular case, the UFOs, when they're instantiated, do a find game object with tag for game controller, and then get component on that game controller and make the reference that way. The other thing that you can do is you can push a reference. So when you're instantiating, to a degree, let's find our spawner. This is our spawner, so let's take a look at where we are. So you could make a public reference here to my controller, because this is instantiated in the game at the beginning, called my controller. And this we can drag a reference to. So coming back and looking at the game, so now our spawner has something we can populate. And you can just drag that. Remember, you're dragging the base game object, even though it's got both of these components on it. So we now have a my controller reference. And then when we spawn, remember, we've got our clone. And we will have to make this public. So this goes back to being public, because otherwise I won't be able to access it without a property or getting and setting or making a function. But now my spawner can say clone dot, oops. Oh, because we're a game object, right. So we're going to need to say UFO controller equals clone dot get component. So you can see how this is going to start to work. Dot get component. That'll be UFO controller. And then we want to say controller dot my controller equals my controller. So what we're doing here, as opposed to having the UFO find it, as opposed to having it found when it's created, we push it when we spawn it. So now this connection is being pushed by the spawner. So the spawner holds that information, and we're pushing it to the UFO. And this should work exactly the same way. Yep, there we go. Can layers be used to filter finding objects? Not that I'm aware of. Melting Sloth. Say we had a bunch of enemy ships for a level managed by a singleton, and on the level being completed, they are no longer used. How would I clean that if that isn't too vague? Melting Sloth, what I would ask is that, are you loading a new scene? Or are you changing your levels in the same scene of the game? So how can I look at variables and functions inside another game object? Harco I. Show how I can look at variables inside another game object. Okay, well, there's a bunch of different ways that we can do that. If they're public, you can just ask, which is partly why you can get into either functions that get and set things, or you can get into actual accessors But let's just create a new script called spawn peeker. Spawn peeker. And I'm trying to think of the best way to do this. Let's just put this here in public. Public int my int equals 5. Now, if you give me a real-world example of what it is that you're trying to do, we can also help with that. So in start debug.log, we need a reference to it, so we're going to need public spawner, my spawner. It's a reference, and then we can say I want my spawner dot my int. So it's public, so we can simply look at it. And then spawn peeker's got to go on something to work. So let's put that in the main camera. And then again, since the spawner is on the same object, so there's our 5. So it's simply public. If it's public, you can simply look at it. If you're trying to start using more, how would you put it? Because I don't want to say that you have to do it this way, but there's some more accepted practices in the way that you write scripts, especially in object-oriented programming, where you're creating private variables and then you're protecting them with either functions that get the value, set the value, or you're using a property. If you want to look at properties, I suggest that you, for the first bit, look at our website, because we talk about that in scripting, and we talk about that. It's intermediate, but we have properties. First one of the intermediate, and it's basically getters and setters, so that you can protect your private variable behind a property, and then you can get and set those values. And if that doesn't answer your question, go ahead and ask for more. No Kitty asks, how do you access variables in a different scene? For example, access score in a game scene from the login screen. You must save those into another form, because when that scene is not running, that scene essentially doesn't exist. It's not being held in memory. So a former score from a scene that is over needs to be saved in some sort of persistent manner. Again, coming back to our site, the suggestion from me to give to you would be to look at persistence saving and loading data. Live archive training from Mike, because you're going to need to save that information before the scene is removed, before the scene is shut down, and save that into some data store, player prefs, or serialize it into a saved file that you can then access. Can you please show us how to destroy all the UFOs with a D key? I don't know how to use a list. I suppose we could do that. Try to be very quick about that one. Let's see. Yeah, okay, so what I would probably do with this is update, because we're looking for input at this point. If our input, learn to type get key down. If input get key down is the key code D. If input get key down D, then what we want to do is, I think we can for each this, for each game object UFO in UFOs. destroy UFO. And if we want to be thoroughly amusing, we could also instantiate our sparks at the UFO.transform.position and rotation of quaternion.identity. So this is just out of my back pocket, so let's just hope that it works. In 3 words, what is serializable variables? I can't find and don't understand tutorials about that. Both Mike and I have done some lessons on that. I look at scriptable objects and persistence of data. But essentially, serializable means breaking down the information or the data that we have in the game and saving it into some sort of recordable string of characters in a more permanent format so that you can transfer that data to another location for storage, and then you can bring it back and deserialize it. And in some cases, because of the way that the information is broken down, some variables are available and are to be serialized, are able to be serialized, and some are not. Some are not able to be serialized without losing some of their data. And what Aleoja, another green name that I can't read, has said is that you need to be serialized to be able to see it in the inspector. Yeah, it's not really a true singleton. I can show you this code. A true singleton will also check to see if there is another instance of this script. So when you're using this reference, it's up to you to make sure you only have one of them. A proper singleton not only gives a reference to itself, but also checks to make sure, which is actually the main reason why it's called a singleton, make sure there's only one. So when the My Controller instance is created, it checks to see if there is another My Controller instance in the game, and if there is, it destroys itself. So that according to the code in the script itself, you can only ever have one My Controller. Whereas in this particular case, you could make many of them and get yourself in trouble. So if you want a proper singleton, it's self-maintaining and you will only ever have one. Steak Pinball, do you really want the UFO? I can make it available. I now have I've twisted the arms of IT, so I can now put simple downloadable files attached to the Learn lesson. So I can include it if you want. If you want to see it. I mean, it's just a bunch of spheres. Speaking of spheres, get rid of that one. So I've squished one, and then put one in the middle, and then I put 4 around the outside. All right, any more questions? We seem to have, calmed down a little bit. I actually got to the end of chat. Ah, it's the man with the green name again. Rimplot, I think. Sorry, it's just that there are a couple of colors of green that Twitch uses for the people's names, and you just can't read them. If I want to reference lots of game objects, is it good to have a different tag for each game object? Will it be faster to use find game object with tag? Can you give me an example? Because a lot of that you can deal with pooling if you don't need to know all of them at once, or making sure they're in the appropriate lists to begin with. An example that I would have of, say, a deck of cards, a little bit smaller, but you have 52 cards, and you instantiate, you have an object representing one of each card. And then when you start a new game, take all of the cards and put them in a new list that's called current deck or something like that. And then when you pick a random card from the current deck, and when you've used it, remove it from the list. Because if you don't, you'll end up with this point where you're trying to pick a random active card, and you've got 48 that are inactive, and it has to look through them all. Hey, which ones are active and which ones are inactive? And so, though it probably wouldn't be noticeable in your game, it's going to slow down the game, the more it iterates until you say, look randomly through this deck of cards until you find the first one that's not been used. But if you take it out of that list, current, so it's got 52 to begin with, and then 40, 51, 50, 49, you will always have a deck of unused cards, because you've got a list of unused cards and a list of your entire deck. When you want to create a new game, you take your entire deck and put it into a new list again, or empty and repopulate the current one. So a lot of this is about manipulating and holding where you have your items. When you create your items, stick them in the appropriate list at that time. It's much more difficult if you approach a scene that's already been populated and then try to grab all of those references, unless you have a specific tag or specific target. The other thing that you can have, like we've seen here with the UFO, is the UFO goes and finds that game controller script. But let's say it does this. On my controller, it doesn't have found me. It has, let's just do this so we don't break it. So let's do another one. Public void register me. And then we want game object. Clone. And then we need a new, we're going to make an array. Let's make a list. I like generic lists. They're just better, easier to do. Using system.collections .generic. Learn to stop worrying and love the generic list. And so then we're going to create a generic list. That's going to be a private list of game objects called my UFOs. And remember to do this in start. Just looking at my stuff we've got down here. Void start. My UFOs is a new list. Oh, that was an interesting code completion. New list game object. Ooh, how I never realized that before. How nice. New list of game objects. And then we can say when we send it, my UFOs.add clone. So when our UFOs are instantiated, they don't just do a find me. They also say my controller dot register me the game object. So now I'm going to make this public just so we can see it. We can look at this in debug. Well, we'll do it in debug mode. I'll show you debug mode. So now, okie dokie, let's get rid of this guy. So now let's look at our main camera, and we're going to go into debug mode. So we can see private information in debug mode. And my controller, my UFOs, and we can see that my UFOs list is growing every time we spawn a new UFO. So we have a list, and the list is maintained by our controller, but we're giving the responsibility of registering into that list to the individual object. So if we want to have all of our UFOs in a list, we could have the controller trying to desperately grab every UFO out there, checking it to see if it's a new one. But in this particular case, every time it's spawned, and since my controller isn't spawning it, the UFOs are registering themselves. No kitty. How do we decide if we go for a new scene or the same scene? For example, when the game finishes, we want to give the option to play again, but also display scores, coins, etc. so far. No kitty. Definitely look at persistence of data in the archives, because that's what that whole thing is all about. Bring it up. Where'd it go? close tabs, please. Did I close it? I think I must have, yeah. So in Learn, in tutorials or live training archive, I just find this is easier to access. Persistence of data, because what you want to do is you want to be saving that information, whether you're saving it to player prefs or some other location. You definitely want to be saving that, the score, you want to be saving the coins, you want to be saving that into a persistent file somewhere. And we talk about the different ways you can do that in persistent saving and loading data. Meier 314, how can I achieve seeing through buildings, walls and roofs around a player character in an isometric game? Should I learn to program shaders? I thought about building a scene using many small parts, for example quads, so I could disable rendering on them individually if they're in the way between the camera, but it doesn't seem to be that great of an idea. I wouldn't say get into programming your own shaders first. I would take a look at the existing shaders, because there are transparent shaders that you could manipulate. The one thing I will say that when you're doing that, take a look at keeping it as a solid shader and then changing a solid material and then changing the shader on that material when you need to make it transparent, because in some cases what I was discovering when trying to fade out more complex objects is it's difficult to know draw order, and so it can look a little bit uncomfortable with a semi-transparent object that is, even if the transparency is pushed all to 100%. Because it's a transparent shader, there is sometimes some confusion as to what comes in front. So what I found was I would leave my solid objects with a solid diffuse shader on them, and then when I faded them out, I would change the material to a transparent one and then activate the fade. Rimplot, is there a way to load data from an external source? Change the language file, change what language file is loaded. Yes, you can definitely load data from an external source. And again, that is in that persistence of data, saving and loading data. And you could have text files that you can use for localization, so you could have different languages for your game. There is a lot of information, mostly from the community, on the forum about localizing games. And there's a couple of things in the asset store to help that as well. Frameworks. It really depends. The question is, what type of files can I use for language files? It depends upon really what you're doing. Text files, in some cases, are perfectly fine. If you're dealing with unimportant data that you don't care if someone finds and hacks up, you might want to bury them deep in a serialized string somewhere if you want it to be slightly more protected. But you can certainly load text. You can make text assets, and a simple text file can be a text asset, and you can refer to it with a script. In some cases, as simple as if player prefs equal Spanish, use span.txt and parse it in. If player prefs are English, use ing.text. So but you can use XML, YML, quite a few different formats. Do I hang out on IRC? I used to. I've just been so busy I don't do it that much, but I do hang out sometimes as Little Angel on the IRC channel that we list in the community, which I'll go ahead and show you now. The IRC people, that's down here. So that's the community page, and there's not really anything I can link to. But it's down here, and you're looking for irc.freenode.net, and then you're looking for the room is #Unity3D. And there's also one called -chat. Can I create a mask for layers so objects from one layer would be rendered only in areas specified by the mask? You can do it. I'm not sure whether it's a mask for layers, but I know that you can do all sorts of funky things, mostly by manipulating your material, which then also means taking a look at your shader. But you can knock holes through things. You can render the background as the foreground. You can have a character that passes in front of a window and isn't visible when they're in front of the window. But that most of that's by manipulating your shader. Updated question from Destu99. What is the best way to suggest live training subjects? Would love some providing easy, normal, and hard gameplay difficulty level. For example, the ability to control the number of enemies. The best way to make suggestions is on the forum. In teaching, free live training. Oops, and someone has answered and I've got to go and talk to them. So that's the best place to give me suggestions because I read through here and I use them. So I need to go. Any more questions? I shouldn't ask that because then you'll ask them and then I'll answer them. I think I'm going to call it a day. So I'll talk to you later. And don't forget, follow us on Twitter, Unity3D, at Mike Geig, at Will Goldstone, and at the Ant Ranch. And post on the forum in the teaching section. Thank you very much.